Hello, good morning to all. Good morning, good morning. Can you hear me?
Good morning, sir.
A very good morning. Good morning, Ira. Good morning, Joshua. Okay, so everyone, good morning. Joshua, good morning.
Good
Sam also joined. Good morning.
Good
Good
morning.
morning, sir.
And a very good morning. Very good morning. Good morning, Abigail. Who didn't join? Edric didn't join and Timmy didn't join. I'll just put a reminder. Everyone is joining.
Hi, sir. I joined.
Hello, Edric. You're late today. Yes, Edric?
Yeah, I'm a bit late today.
Uh-huh. It's okay. Good morning to all. So we'll start our class. So I hope yesterday the homework which I gave you are doing it seriously. Okay. Ira, did you saw the yesterday class?
Oh, sir, I didn't get time. I'll do it when I'm free. I think like today or tomorrow.
Oh,
During
okay, okay. No problem. No problem. Today basically we will start a new classes only. I mean new topic only. So it's not related to the previous one. So it's okay. And else everyone did the homework. Do you have any doubt in that? Jashron, Edric?
No, sir. I finished the homework, sir.
Very good. Very good. Very good. Joshua, Abigail, do you have any doubt in that, the homework which I gave yesterday?
No, sir.
No? Simeon?
No.
Okay. So shall we move forward or do you have any doubt? Justin has any doubt? Vidya, do you have any doubt?
No doubts, no doubts, no doubts,
Sir.
sir.
No doubt? Okay,
No.
then we will start new topic, okay? Because you guys doesn't have any doubt. Because I'm a good teacher, that's why we will start our class. Okay. So the first identity that today we're gonna learn is A plus B
The whole.
whole. Yes, whole cube. Now the cube thing came. Basically, a plus b whole cube means a plus b whole cube means that a plus b will multiply with a plus b will multiply with a plus b. Okay, we don't write it, but just for your understanding, I am telling it to you that a plus b whole cube means a plus b multiply by a plus b multiply by a plus b. Now its identity is there. Okay, and how it came? Like we normally were by multiplying it. Okay, but I will not multiply it. We will learn the identity, and the identity is a cube plus b cube plus 3ab into a plus b. I'll repeat it again. A cube plus b cube plus 3ab into a plus b. Understood? Simeon, did you understand?
Yes.
Yes. So I'll repeat it again. A cube plus b cube plus 3ab into a plus b. Okay. This is the identity. And the second identity is basically it's it's not the it's not the same thing, but it's basically multiplying it. So how it will become a cube plus b cube, and then it will multiply with both the numbers. It will become 3a square b plus
3AB.
3b square a. Basically, what I did, I just multiplied 3ab by a and 3ab by b. So when I will multiply 3ab into a, it will become 3a square b plus 3b square a. Understood? Yes or no?
Yes, sir.
Okay. So this is the question. So now, for example, if I will write a minus b whole cube. Now, what's the identity? So the first identity is a cube plus b cube minus 3ab into a minus b, and the second identity will be a cube plus b cube. So again, I will multiply with both the signs. It becomes minus 3a square b plus 3ab square.
No, sir, it should be a cube minus b cube, not plus b cube.
Yeah. Sorry. Good. Understood, guys? Joshua, Sam, Ida. So these are some identities that we have to learn. Okay, how it came? It's just by multiplying it. So we will not go in that thing, but we have to learn these both these identities. This one also and this one also. Like basically two identities we learn, and there is a four formula. So we know that the second formula of each identity is basically derivation of the first identity only. Understood, Jashram? Yes or no? Quickly write it down. Quickly. Then I will give you questions.
Done. Finished writing both.
Yeah.
A cube. Cube.
Done? Shall I raise this? Shall I give you one question based on this?
Yes, please.
Yes, I will give you one question. I'm not erasing it, but I'll just write the question. Okay, quickly do it. Simeon, did you understand, beta? Joshua, Sam, Abigail, any problem? Ask me.
Yes, sir. Sir, can you hear me?
Yes, I can hear you. It's clear, crystal clear. Simeon, steps are important, okay? I need steps, okay? Just not any problem? Done? Shall I raise this? Okay, listen, guys. Now it is in the form of a plus b whole cube. Yes? Now where a is equals to 2x and b is equals to 7. So if I will put, like, what is the identity of this? A cube plus b cube plus 3ab into a plus b. So what I will do? I will put the values into this. So, like for example, what will become? 2x cube plus 7 cube plus 3 into 2x into 7. In the same way, 2x plus 7. Understood, guys, what I'm doing? Simeon, did you understand? Bethia, did you understand?
Yes, sir. I already got
So,
it.
okay. So now 2x cube. So it will become 8x cube plus 3 cube. Sorry, 7 cube is 343. So 7 cube plus 2 3s are 6. 6 sevens are 42. So 42x into 2x plus 7. This will multiply with this also and with this also. So it will become 8x cube plus 343 plus 84x square plus 14, 15. 294x. This is the answer. Did you understand, Ira? I didn't understand anything. Please ask me.
Sir, can you explain the last part?
Yeah, yeah. See, I just multiply this 42 with both the terms inside the bracket. So this 42x will multiply with this 2 also, 2x also, and this 42x will multiply with this 7 also. So 42x into 2x will become 84x square, and 42x into 7 is equals to 294x. Understood? Sam?
Yes, sir. Understood. Thank
Yeah, yeah, Ira. What's your doubt, beta?
So after you explain it again.
Shall I explain it again?
No, I understood after you explain it again.
Okay, okay. Now you understood everything? How to solve this question?
Yeah.
So easy.
Oh, बहुत easy. Yes. Jashan, did you understand, beta? No, please ask me. I'll help you.
I used the second identity, sir. I got the same answer.
Good, good. Abigail, do you have any doubt, beta?
No, sir. I just made a mistake. Like I added 7 and 2x.
Wow, wow.
Yeah,
So it's not a mistake. It's blunder.
yeah.
Okay, I'm erasing this. Okay. Shall I erase this?
Yes,
Wait,
sir.
I'm copying.
Sorry, Simon saying something.
Nothing.
Do you want me to again? I'll go reback. Are you
Yeah,
copying, Simon?
I'm copying.
Yeah, yeah. Write it down. No problem. Take your time. So, do you have any doubts, Simeon?
No.
Okay. So, what breakfast you have, Abigail? Dosa? Idli?
No, sir. Today was Bombay toast.
Bombay toast. Oh, my favorite.
Yeah, and it actually the weather is very hot here, but suddenly today it started raining. So
I'm done copying.
Oh,
yeah,
wow, wow.
so it is very nice.
Okay, okay. Okay, do this question, please. Simeon, any doubts? Please ask me later.
No, no doubt.
Okay.
Got it.
Hello? Yeah, done. Everyone done? Edric, please send me the answer in chat, no? Who's not done? Turn on the camera, everyone. Bethia, Joshua, Sam.
Hardik sir,
Yeah.
my network is bad, so is it okay if I keep it off?
Okay. Try to fix the camera. I mean, network.
I cannot do that.
Okay. So now it is in the form of a minus b whole cube. Yes. So now if it is in the form of a minus b whole cube, so if I will compare it, I will get that the 2 by 3x is equals to a and b is equals to 8. Now what is the identity of that? It's a cube minus b cube minus 3a square b plus 3b square a. Okay, I use the second identity. No problem in that. You can use that. Now I will put the values into it. So it will become 2 by 3x whole cube minus 8 cube minus 3 into a square, which is 2 by 3x square, and b is 8 plus 3b square, which is 8 square, and into a, which is 2 by 3x. So it will become 8 by 27x cube minus 8 cube is 512 minus 3 into 4 by 9 x square into 8 plus 3 into 64 into 2 by 3 x. So 8 by 27 x cube minus 512 minus 3 4 the 12, 12 8 the 96, 96 x squared by 9 plus 3 to the 6, 664 the, okay, we can cut this 3 and with this 3 also. So it will become 64 to the 128x. We can cut this also, so it become 32 by 3. So the final answer will be 8 by 27x cubed minus 512 minus 32x squared by 3 plus 128. This is the final.
Yes.
Ira,
I
you
also
didn't
got
understand? Very good. Ira?
I sort of understood.
Yeah, where you got stuck? Tell me,
Wait,
I'll
just
help you. Sorry?
For like, how did you do like the first part? Like, what did you use? Like, what
This
was
thing.
yeah.
See, when I will compare this question with the identity, because I remember the identity, na? But when I will compare it, so I will find it out that A is equals to what? 2 by 3x.
Okay.
And B is equals to what? 8. Okay, now A minus B whole cube is there. So if A minus B whole cube is there, then what is the identity of that? We just learned this identity. And the A, yes. Yes, please.
So we have to use the second identity that we learned.
Yeah, because minus is there. So A minus B whole cube. So when you will learn that, okay, this is the question and which identity we can use. So if you learn that, then it is only to just substitute the value of that thing into the identity. Understood? No.
I understood.
Pakka?
Yeah.
Okay. Abigail, where you got stuck, better?
I didn't get stuck, sir. I got the right answer.
Oh, very good. I believe that you didn't add or you didn't do something blunder. Hmm? Jashan, where you
Yes,
got
sir.
stuck?
The multiplication cubes is a little tough for me, so I was doing that.
Oh, okay. Simeon, where you got stuck, beta?
I didn't get stuck.
Yes. So you got the answer? Same answer?
Yeah, but I think I did less steps.
Less steps. See, that's why I'm saying steps are important. Okay. Can you show
I
me your
missed a
answer?
step.
Okay. Can I see your steps, please? See, guys, this writing this identities is also get like it's a marks. It's count as step. Edric, are you writing this identity?
Yes, I'm writing the identity also.
Yeah, that's good. Because if you not write identity, then you will lose your marks. Abigail, not writing identity.
Sir, I wrote, sir. I can show you my notebook also.
Yeah. So first, let me see the Simeon one, and then I will see your Abigail's one. Yes, Simeon, please show me.
Okay.
Simeon, are you there? Okay, Abigail shows yours notebook.
Me, sir.
Yeah.
Yeah, sure.
Can you see her?
Yeah,
Here.
yeah, I can see it. I can see it. Okay. Perfect. Perfect. Good. Good. Okay. Simeon is here. No, Simeon network is gone. Okay. So we learned these two identities, which is a plus b a cube. Okay. Now the third identity that we're gonna learn, the third identity. I'm erasing this. Okay. Simeon, are you there? Can you hear me?
Yes. My internet went for
Yeah.
a sec.
Yeah, yeah.
Can I
Okay.
keep
So
my
third
video
identity.
off?
Yeah, it's okay. Okay. Now the third identity is a cube minus b cube. Okay. Now what is a cube minus b cube? See, a cube minus b cube, the identity is a minus b into a square plus ab plus b square. This is a cube minus b cube. This is what? A cube minus b cube. So if I will solve it, so this a will multiply with whole trinomial term. It's gonna be like this. Sam, are you getting this? No. Joshua, Sam.
Yes.
Sir, sorry, sir. This entire time I had to go pick up a parcel from outside the gate, sir. I just came back. Sorry.
Okay, okay. So did you understand what I'm doing in the class?
Until I left, I understood, sir. So I started.
Okay. So what I did, this a will multiply with whole trinomial term. This minus b will also multiply with whole trinomial term. So if I will multiply it, so this will multiply with whole term, so it become a cube plus a square b plus b square a. The same way, this will also multiply with whole trinomial term, so it becomes minus b square a plus
B plus a square
sorry
b
sorry 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 minus a square plus sorry plus नहीं आएगा minus
minus
minus minus
a square.
b square a minus b cube. So basically what I did, this minus b is multiplying with whole trinomial term. So this minus b into a square is minus b a square. This plus ab. So this minus b will multiply with this minus b square a, and this minus b will multiply with this b square makes b cube. Understood? Yes or no?
Yes, sir.
Okay. So now when I will solve this, so it will become a cube. Now basically this plus b square a, this minus b square a can be 0. This and this will also be 0. So the remaining behind a cube minus b cube. So it means that a cube minus b cube can also be written as a minus b multiplied by a square plus ab plus b square. Guys, did you understand?
Yes,
Simeon,
sir.
Bethia, Joshua, Sam, Ira,
Yes, sir.
any
Understood.
problem?
No, sir.
Jashwan, any problem you are facing right now? No? Okay. Next, fourth identity. The fourth identity that we gotta learn is a cube plus b cube. So a plus b into a square minus ab plus b square. Okay. Now basically this is a similar to the above one. The difference is if plus is there, the plus will be there. If minus is there, the minus will be there. And one more difference is if minus is there, plus will be there, plus will be there, minus will be there. So
Sir,
basically the sign will exchange here and here. Yes.
then how is there a minus over there? There's a cube plus b cube. Then how is minus over there?
Where? Here.
Yes, there's a minus there.
So now I urge you to solve, to check that the identity which I wrote is correct or not. And how will you check it? Like
Sir,
you
you
can.
try and solve it, sir. So it will become a into a square minus ab plus b square plus b into a
Mhm.
square minus b square.
Yeah. Then
And then it will become a cube minus a square b plus b
yes,
square a
yes,
plus a square b
b cube. Yeah.
minus b square a plus b cube.
Then we got na a cube plus b cube because minus b square a and plus b square a will be 0. Minus a square b plus a square b is 0. So the remaining behind a cube plus b cube. Understood?
Yes,
Edric? No.
yes, sir. Yes, sir.
Ira, did you understand what I'm doing in on the board? Or any doubt, please ask me.
Yes, I understand.
Abigail, Jashron, Bithya, Joshua, Sam, Hardik. Oh, it's me only. So everyone understood?
Understood, sir.
They could.
Uh, okay. So now we learn about four identity. I'll give you one question. Shall I raise this? Or Simin is still writing? Simin, are you writing, beta?
I'm also writing.
No, I'm done writing.
Okay. Okay, quickly write it down. Tell me when you're done.
So will it be the same if it's a plus b, a square plus ab plus b square?
No, it won't be same. If plus plus is there, then there's like here we are getting the plus a square b and then minus b square a. Basically, they can be reduced to zero, na? Because plus minus is there, no? That's why. If plus plus is there, then it won't be a cube plus b cube, but it will be the whole big equation will be there. Understood?
I'm done writing.
Done? Shall I raise this?
Done, sir.
Good. Okay, do this question, please. Wait. Oh, बना पड़ा है ना.
Sir, sir,
Yes, Abigail.
suddenly, like, I just remembered for the previous sum,
Hmm.
where we did a minus b whole cube.
Yes.
In the identity, I had written a cube minus b cube minus 3ab within bracket a plus b.
A minus B will come.
Yeah, but I solved it with. Okay, I only wrote the identity wrong.
Yeah. A minus B will come. Yeah. Now I want answer from Sam, Bethia, Joshua, Simeon.
Why me?
Josh, the one who has camera off. Like I'm saying, not like why me. I want to check now that are you there or not.
Done.
Yeah. Who said? Who said? Edric said. Okay. Yes, Edric done.
Why is it 3U1?
Sorry, beta. Say it again.
No, it's 1 cube plus 4 by 3 C cube.
Hmm.
And then you've written plus 3U1 square.
No, it's not you. It's one. You missed the gold medal handwriting. Is it now one?
Yes, now it's one.
Yes.
I got the same answer, sir.
Good. Ira, you got the same answer or you got stuck somewhere else?
Sort of, sir. I didn't know I had to put like the 3 cubed there.
Which part?
I like after the beginning, like 4 by 3 and then C cube. And then plus, I didn't put the 3 there, like the 3 cubed and then 1.
Okay. So the identity is 3a square b, na? So that's why I put 3. 3, like normally 3 will come because the identity is there. Understood, Ira?
Understood.
I'm just following the identity and putting the value of a and b respectively. Like a is 1, na? So I normally put the value of a as 1.
Okay.
The 3 I didn't put somewhere else. It's in the identity. That's only I'm putting it. Jashran, where you got stuck?
I got it, sir.
Okay. Joshua, where you got stuck?
I got it, sir.
Okay. Sam,
Got it, sir.
Sam, got it. Betya,
I got it.
Same answer.
Simeon, you got it.
I got it, but I'm writing it down.
Okay. Figure it
Like
out.
I understood what you wrote, but I'm writing my own answer now.
Okay. Okay. No problem. Okay. We can do it, and then we'll do last topic, and then I'll give you the little homework.
Sir,
Yes. Yes, yes, Abigail.
I made a mistake. I didn't write 4C. I only wrote 4 and then I added 1 and 4 and I got 5.
Gail.
Yeah, so I got a wrong answer.
Addi kittum.
I was going to tell you, sir, why is your answer different? I thought like you made a mistake, but actually I made a mistake.
Addi kittum. Abigail, addi kittum.
Sherry, sir.
എന്തിനെ വെറുവ അടി കിട്ടും. എന്തിന് is not no. എന്തേ no ഞാൻ വീട്ടിലെ വെറുവ അടി കിട്ടും. I think it
Full
is correct.
sentence wrong.
Sir, it's ഞാൻ വീട്ടില് വന്നിട്ട് അടി തരും.
Yeah, same one. Same one. Okay, shall I read this?
Yes, sir.
Okay. So now the same thing, number 1 will also come, like 101 cube is there. So if 101 cube is there, so can I write it like
100 plus
100
1.
plus 1? Yes. 100 plus 1 cube. So now Ira will tell me. Ira, this 100 plus 1 is in which identity form?
That a plus b cube.
Now what is the identity of that?
Then I
Yeah, you can see it. No problem. But
A
by the end of this week, learn all the identities. Okay? Yeah, please.
it's a plus b, then a plus b, and then a plus b, right?
Yeah, this is the normally writing form, but the identity I gave it to you, na?
A cube plus b cube
Yes.
plus a 3a squared b plus 3b squared a.
Okay. So it means that now here, if you will compare what is A
Is 100
and what is B,
1.
good. So can I write the values into this? So how it will become? It will become 100 cube, then
1.
3 into 100 square into 1 plus 3 into 100 into 1 square. Okay. Now if you will use this, it will become 1, 2, 3, 4, 5, 6. See guys, it's a trick. 2 zeros are there and 3 is the power. So when you will multiply it, it will become 6. So 6 0 will come. Understood? No need to multiply 100 into 100 into 100. 2 zeros are there. 3 is the power. So 2 3 are 6. So 6 0 will automatically will come. So it 1 and it will become 3 into 1, 2, 3, 4 plus 300. It will become 1, 2, 3, 4, 5, 6. 30,000 plus 300. It will become 1.
103001.
Yeah, 1 0 3 0 0 no, 3 0 3
1030.
0. Correct. This is the correct answer. Understood, Ira? Simeon? Just on?
Yes.
Understood, better? Any problem, ask me, please.
Yeah, sir, I understood. Made a small mistake. It's okay.
Yeah. Abigail, now you didn't add it?
I got it correct, sir.
Okay. Good. Good. So now there's a little homework, which I love it. Okay. So
Very.
today I will give you a little homework. Yes, very little. I can understand your burdens and all. So that's why I will give you a very little homework.
Sir, please give little, like lesser than yesterday's homework. That was not little, that was very long.
I
Exactly.
By the
yeah, I
way,
will give.
sir, you said you gave 20 sums, but you only gave 18.
Today I will give
What are
more
you
than
saying
20.
that for? He'll give us some more today.
No, don't worry. He only taught us so many concepts. I know how much he'll give.
Yeah, yeah. Yeah, okay. Okay, okay. Okay, okay. UIP 4.2. Question number 1. Cool. Abigail, write this thing or take screenshot or make a cutout and put it in the group also, so that everyone can remember this.
Oh, question 1. Okay.
Okay. This much only. This much only.
So you've given 26 sums.
Yeah, yeah. So you ask me,
Like 5 sums or 4 sums.
but homework, like I can understand your feeling, guys. I didn't. Normally used to give 100 some, but I restricted myself to 26 some because God has mercy on me. So I same thing I did it. Okay. So today we'll stop this maths class. I hope you enjoyed the class. Till then, bye Abigail and Asamian. And tomorrow we'll meet with new fire. So one more thing, we'll have 4 minutes break. Then we'll start our science class. So everyone go and take break and then come back at 10:52. Okay. Bye Simeon. Bye Abigail.
Bye, sir. Thank you.
Bye,
Thank
thank
you.
you.
Bye.
Wait,
Thank
how
you.
do I leave? All right.
Okay, done. We'll start our science class. Everyone come back. Come back. Yes, good. Where is Jehoan Jeshurun? Is it there? Yeah. Camera is like shifting, like when I say Jehovan. So like it's shifting towards Jehovan. Okay. So we'll start this. Okay. So we did it till discovery of proton. Yes. And we did this Thomson model also. And we learn about Rutherford scattering also. So for Ira, so you can go and watch the video. And if you have any doubts, then you can just normally ask me tomorrow with your doubts. Okay.
Okay.
Okay. Now, like we'll go for the Rutherford one more time. So Rutherford, what he did, like small brief introduction I can give. Okay, what Rutherford did, that Rutherford basically he he take alpha particles, and can anybody tell me what is alpha particle is made up of?
Helium
Alpha
atom
part,
without
yes, helium plus plus. Basically, alpha particles are called as helium plus plus. It's heavy positive charge. Okay, heavy positive charge. And with the alpha particles, when he took a thin gold foil and he bombarded it, so he finds some results. Like normally when he bombarded it, so like normally it should happen that the alpha particle should go and directly pass the gold foil. But when alpha particle hit the gold foil, then there is some deflection, some deviation was there with the small angle. Second, it was a large angle also. And the third, which is very rare, like 1 out of 12,000, one ray come back to the same path. So it means that there is something is there in the gold foil that is responsible for the deviation of the alpha particles, which is heavily positive particles. See guys, this is very important because this only helps us for the finding the protons, like for finding the place of protons. Okay, so from this calculation, what they find it out, see guys, they find it out that gold is made up of which atom? Silver atom.
Gold.
Yes, gold. Gold is made up of silver atom, na?
It's made up of gold atom. It is like 79 protons and 79 electrons.
Yes, good. So gold is made up of gold atom. So if gold is made up of gold atom, so in the gold atom there is some protons and there is some neutrons and electrons. So
There are
basically,
79 protons and 79 electrons in a gold atom.
good, very good. So it means that the electrons are basically revolving around the nucleus. Yes, like I told you this structure, na? I told you this structure. So right now this structure is not there. Like when Rutherford doing his experiment, he doesn't know this structure. Okay, he was just finding out what is like what is where is proton, where is electron. So basically what was there that in gold, like this is for example this is an atom. Okay, and he find it out when the alpha particles are traveling like this. Okay, when alpha particle was traveling like this, then it's basically going straight. It's basically going straight. But when alpha particle going near to the nucleus, it got deviation with a small angle like this. Understood? It got deviation with a small angle like this. Okay. And if alpha particles are hitting very like nearly center to the nucleus, then it deviated with the great angle. And the rare part is when the alpha particles are coming like the center of the nucleus, it is moving in the same path. So basically, we have these types of lines are there. The yellow lines is there when it is not hitting the center part. When it is not hitting the center part, it's going straight. But when it hit or goes near to the center part, then it deviates with a small angle. But when it hit the nucleus, about to hit the nucleus, then it deviates to the great angle. And 1 out of 12,000, it come back like a green line. So from this, what he observed that, see, he observed that the that there is something center is there, which is stopping the alpha particle, which is not allowing the alpha particles to move through it. Because in the first, this yellow line, there is empty space should be there. That's why the alpha particles are going directly. Okay, but in the center, something is there. So he tell this center as nucleus. Understood, guys? Yes or no?
Huh?
He
Sir, sir, sir.
yes, yes, please.
So that's how nucleus was discovered.
Yes, that's how the nucleus is discovered. He discovered that atom, like in the center, there is some mass is there. Like whole atom mass is concentrated in the center, and that's why the alpha particles are not moving through it. And he also tells that because the deviation, why deviation is occurring? Why deviation is occurring? Because I told you in the starting, there is positive charge called as helium. Yes, the positive charge is called as helium. Yes. Now deviation normally occur. For example, if you will keep north pole and north pole to each other, near to the each other, what will happen, Ira? If you will keep north pole and north pole to near to the each other, then what will happen?
They'll go in opposite directions, like the
They will
same.
they will have repulsion.
Yeah.
Yeah. Like if there is a negative charge here, then there won't be any deviation. Why? Because negative charge is this and the helium is positive, so they both attract to each other. But there is something in the nucleus is there which is positive in nature. Positive in nature. And that positive in nature is called as protons. So he concludes that the center is called as nucleus, where all the mass of an atom is concentrated. Second thing, that nucleus is consist of positive in nature called as protons. Understood, guys? Jehovan didn't understand. So it means that the center nucleus is basically consist of positive charge called as protons. Called as protons. That's why the deviation is occurring. Okay? And the rest of the atoms other than the nucleus is basically an empty space or have negligible mass. Okay, and if you will check that here the yellow line which is going, it's going straight, there is no deviation in that. Why? Because the rest of the atom is basically the electrons are there. Basically what is there, electrons are there. That's why negative charge and the positive charge are attracting and there is no deviation is there. Understood, Jashron? Betya, Joshua, Sam, did you understand?
Yes, sir.
Yes or no? Give me a second. Yes. Everyone understood?
Yes, sir.
Yeah. So this is some conclusion is there. Let me check one or other conclusion is there. No. So we'll read this conclusion. I hope you understood the concept of how Rutherford did the experiment and how he discovered nucleus and the protons, where is the protons position is there. Understood, Joshua? Okay, so I urge Joshua to please read this.
An atom contains a dense and positively charged region located at its center. It was called as nucleus. All the positive charge of an atom and most of its mass was contained in the nucleus. The rest of an atom must be empty space which contains the much smaller and negatively charged electrons.
Yeah. So basically, the positive, the negatively charged and the smaller are basically around the nucleus. Okay, the electrons are basically around the nucleus. So this is how Rutherford explained his experiment. Now, next part. Yes, please read this.
On the basis of the proposed model, the experimental observation in the scattering experiment could be explained. This is illustrated in figure 5.6. The alpha particles passing through the atom in the region of the electrons would pass straight without any deflection. Only those
See, this is
particles.
very important line. Uh, Guys, please pay attention. This is very important line. The alpha particles passing through the atom in the region of electrons would pass straight without any deflection. Only those who come close to the vicinity of the positively charged nucleus get deviated their path. They can ask you how Rutherford detect that electrons are there around the nucleus. This is the reason that when alpha particles, which is heavenly positive particles, pass far from the nucleus, then it doesn't show any deflection. That's why there is some electrons, negative charge are there. That's why it's allowed to pass the alpha particle in a straight line. Understood? No, I didn't understand anything. Please ask me, Ira.
I understood, sir.
Understood? Yeah. Okay, underline this thing in your book also. If you have book, please underline this. Okay. Edric, please read from here, please.
Very few alpha particles, those that collide with the nucleus, would face a rebound. On the basis
Yeah.
of this model, Rutherford was able to predict the size of the nucleus. He estimated that the radius of the nucleus was at least 1 by 10,000 times smaller than that of the radius of the atom. We can imagine the size of the nucleus with following analogy. If the size of an atom is that of a cricket stadium, then the nucleus would have the size of a fly at the center of the stadium.
Yeah. So you can compare it. A stadium and the fly, like mosquito fly in the center. So what's a comparison? No? So that's how he find it out that the Rutherford, like the atom, is like a cricket stadium, and a fly in the center is a nucleus, which have protons. Understood, guys? Yes or no?
Yes.
Okay.
Sir,
So yes, please.
but the nucleus contains protons, and protons are heavier than electrons.
Yes. Yes.
That means the electrons are spread all around.
Yeah. Electrons are like men's or women's in the or the people in the stadium.
Using this cricket stadium analogy, the electrons will be like grains of dirt or even microscopic.
Yeah, it everything is microscopic. You can't see atoms from your eye. Everything is microscopic, but the thing is how the nucleus is concentrated in the center and it have all the mass of the atom. That's the main point. Yes, Jehovah. You're saying something, Jehovah. Yes.
No, I wasn't saying.
Sorry.
I was not saying anything.
Okay. No problem. So this is your homework, little homework. Exercise 5.2 is your homework. Okay. So now this theory which Rutherford gave, it's also, I'm not saying it failed, but it's not complete. Okay, I'm repeating again. I will not say it's failed, but there is something is also missing. Like Rutherford tells us that normally, like this is a nucleus, okay, and electrons are revolving around the nucleus. He told us like this. But if there is basically called as dual nature of a particle, in which if something is moving, it is like it will have energy also, and it will lose energy. So if it is like this, then if for example electrons are revolving around the nucleus, okay, then after some times, after 1 year, 2 year, or 5 years, the electron will lose its energy and it will collide with nucleus, and same thing will happen. Like everything after 5 years, your table will go bomb. After 7 years, your pillow will go bomb. Huh? It's not like that, no? Rutherford said that electrons revolve around the nucleus. If positive and negative charge will meet, there is a spark. There is a like blast. Okay, because there is instability will be there in the atom. So it means that after 8 years, your sleeper will get bomb. Blast. Is it not like that? No. So that's why I can't. I will not say it's failed, but it is incomplete. Something is missing. That missing part is done by Niels Bohr. So first we will understand what is the drawback of Rutherford. Now this question usually come in the exams with the question with the marks of five marks question. Understood? So we'll read this. Yeah. So I'll ask Sam to read this. Sam, please read this.
From where,
Sam,
sir?
are you there?
According,
Yeah.
from according?
Yeah. Yeah.
According to Rutherford's model, the negatively charged electrons revolve in a circular orbit around the positively charged nucleus. However, according to Maxwell electromagnet theory, if a charged particle accelerates around another charged particle, then it would continuously lose energy in the form of radiation. The loss of energy would slow down the speed of the electron. Therefore, the electron is expected to move in a spiral fashion around the nucleus and eventually fall fall into it as shown. In other words, the atom will not be stable. However, we know that the atom is stable and such a collapse does not occur. Thus, Rutherford's model is unable to explain the stability of the atom. You know that.
So basically, I told you, na, if electrons is revolving around the nucleus, after sometimes it will lose energy and it will go and collide with the nucleus, and then blast will be there. But it won't. It is not there. Why? Because there is something is also there which Rutherford is not able to explain. Okay. Yes. Please read this. Yes, Sam.
Rutherford's model is unable to explain the. Oh, I already read that, right? Yeah. You know that an atom may contain a number of electrons. The Rutherford model also does not say anything about the way the electrons are distributed around the nucleus. Another drawback of the Rutherford model
So
was
we
its
basically we have three drawback right now. So you guys have to like if you can write it down that what are the drawbacks of Rutherford models, then please write it down. Okay, and write this answer also. The loss of energy would be slowed down of the no. Just give me a second. Yeah. Electron around the positive nucleus. However, charged particles. Hmm. Mhm. Okay, this is the first point. Okay, this is the first point. The Okay, I तो बता रहा. Rutherford model is unable to explain the stability of the atom. Atom contains some number of electrons. This is 2 point. Okay. And the third point is this one. No, this is third point and this is fourth point. Okay, read this, please.
Me, sir?
Yeah, yeah. Please read this.
Somewhere. The Rutherford model also does not say anything about the way electrons are distributed around the nucleus. Another drawback of the Rutherford model was its inability to explain which is the relationship between an atomic mass and an atomic number. This
Yeah, so
problem was
atomic mass and atomic number is also a problem because Rutherford is saying that, like for example, we'll take example of chlorine and 17. So the Rutherford says that chlorine atomic number is 7. No, not 7. Like for example, he's saying 12. Okay, but actually the atomic mass is different. So atomic mass and atomic number relationship is not able to find it out. Yes, Edric.
Sir, the
Yes,
atomic number of nitrogen is 7. Atomic number of 12 is magnesium. Atomic number of 17 is chlorine.
chlorine. Yes, it's correct. Right now we know that. But when he was finding it out, he's not able to explain the relationship between atomic number and atomic mass. That's also become a drawback for his theory. Understood? No.
Yes, sir. Yes, sir.
Yeah. Now the hero entry is there. Okay, he's called as Niels Bohr. Okay, I know that science class is a little bit boring, but he's the Niels Bohr. Okay, now Niels Bohr came with his ideology of getting the relationship, like whatever the drawbacks is there in the Rutherford model, he fulfilled it. And right now, whatever we are learning, it's by the postulates of the Niels Bohr. And this is 5 marks question. One more time. Okay, 5 marks question. They can ask you what are the postulates of the Niels Bohr. You have to write it down. This is very important. Okay, so I'll ask Bethia to read this. Please, Bethia. Bethia, are you there?
Their network is very bad.
Okay, so you're not able to see.
It's very like blurry and all that. So like I have to keep on keeping it on the other side of the table.
Okay, you go in downstairs, no?
Yeah, but stuff is going down. She's doing something and all that. So that's why I'm upstairs.
Oh,
Also, this is
okay, then I will ask Ira. Please, Ira, read this.
Postulate 1. The electrons
Hmm.
move in definite circular paths of fixed energy around a central nucleus, just like our solar system, in which different planets revolve around the sun in definite trajectory. Similar to the planets,
Yes.
only certain circular paths around the nucleus are allowed for the electrons to move. These paths are called orbits or energy levels. The electron moves in the orbit, does not radiate. In other words,
Yeah. So basically, what he said, like what was the drawback? First drawback is that if electrons are revolving around the nucleus, then it will radiate some energy and it will form a spiral path and it will go and collide with the nucleus. That is a drawback of Rutherford. Now Niels Bohr came that like it is correct. It is correct that like in the center it's a nucleus and electrons are revolving around it. But electrons are revolving in a trajectory, some imaginary arbitrary cells. Okay, like electrons are revolving around like in our solar system. Center is sun, and all the 8 planets are revolving around the sun. Okay, did you heard that Earth is going and will collide in Sun? No, no. They have own orbits, own trajectory paths. Yes or no?
Yes, sir.
So in the same way, electrons which are revolving around it, they are moving in each orbital levels, and they have their own energy. For example, if this has energy of 1, so this will have energy of 2. This will have energy of 3. So it's not fixed, but I'm just telling it to you that each orbital level have their own energy, and electrons are revolving around here in the stationary energy. Did you understand, Jehovan? Yes, each orbital level have their own energy. We can see that similar to the planets, only certain circular paths around the nucleus are allowed for the electrons to move. These paths are called orbits, and the electrons moving in the orbit does not radiate. So those who are in, like for example, this electron, you can see that it's moving in E1. Then you can see that it won't radiate because it's have its own path, like Earth revolving around the sun. Na? Earth never radiate energy to go and collide with the sun. No, it's not there. No, the same way electrons is also not radiating like that. Did you understand, Ira? No.
I understood, but like you said, it may come the question. So if the question comes, we just have to write the electrons move in definite circular paths of fixed energy around the central nucleus, or do we have to like bar the whole thing and write it?
If they tell you to explain in detail, then you have to write the whole thing. But if like 3 marks question is there, okay, then you normally write the postulate. But if 5 marks question is there, 6 marks question is there, then you have to write the postulate as well as, and you have to explain it also.
Okay.
Okay, so it depends on the marks. Okay, Edric? Like if the marks is 3 marks, like Edric and I guess Edric in this class and Simon has in this class, they attend level C class taken by Rebecca ma'am. So what Rebecca ma'am used to do, she used to kept saying to them that write the answers in detail. Okay, so that if 3 marks question is there, then you have to write 3 points. If 5 marks question is there, then you have to 5 marks. Okay, so basically these are the some criteria that you have to do. 3 marks question, little brief. 5 marks question, minimum you have to write 14 to 16 lines about that. So you have to elaborate it also. The same
Okay.
question they can ask you in photosynthesis. What is photosynthesis? Photosynthesis is preparation of the green plant. It's 1 mark. Preparation of food by green plant. Like if 3 marks, it can be there like with the help of this and this and this, the photosynthesis occurs. 5 marks question is there. You have to write in the chlorophyll, in the stomata, water takes, and then in the presence of sunlight, and then you have to write reaction also. You have to balance it also so that you can get the 5 marks. So same photosynthesis question is there, but in different parts you have to elaborate it. Like that we have to work, and I will work with you, and I will give you test. Okay, and when I will check it, so I will tell it to you. Okay, this problem is there. This problem is there. You have to solve it like that. Okay, so yeah, the electrons read this, Ira.
The electrons moving in the orbit do not radiate. In other words, it does not lose energy. Therefore, these orbits are called stationary orbits or stationary stats. The bold concept of stationary state would answer the problem of stability of atom faced by Rutherford's model.
Yeah,
It
read
was
this.
It was later realized that the concept of circular orbit proposed by Bohr were not adequate, and it was modified to energy shells with definite energy. While a circular orbit is two-dimensional, a shell is three-dimensional region. The shell of a definite energy was presented by letters K, L, M, N, etc., or by positive integers 1, 2, 3, etc. Figure 5.8. The energies of the shells increase with the number n equal to 1. So next page.
I'm saying that electrons are basically revolving around this, and they have their definite energy. That's important. Definite energy is there. Okay, which doesn't allow the electrons to radiate its energy to go and collide with the nucleus. That's the main thing. Okay. So we'll stop here only. Tomorrow also we'll start with the postulate one only. Okay, so that we can go more deeply about it. Okay, understood, guys? So we'll stop here. I hope you enjoyed the class. Till then, bye. Have a nice day. Signing off. Tata, bye bye. Sayonara.
Bye,
Bye, sir.
sir. Thank you, sir.
Thank you.